Hey guys, so this is Unit 7 and we're on day 9 and we're going to talk about proportions involving line segments. So in our warm-up it says that a flagpole casts a shadow 16.60 meters long. And it says Tim stands at a distance of 12.45 meters from the base of the flagpole. Now Tim could basically be standing anywhere around the flagpole 12.45 meters away. But this is a huge clue that says such that the end of Tim's shadow meets the end of the flagpole shadow. Shadow's going in the same direction. That means that Tim is standing in the flagpole shadow. Okay? And it says that Tim stands at a distance of 12.45 meters from the base of the flagpole. So this distance here is 12.45. A little bit tricky that the two lines lengths overlap. Okay? And it says if Tim is 1.65 meters tall, determine and state the height of the flagpole to the nearest tenth of a meter. So what they want you to try to see is that there are two similar triangles in this picture. So we have a triangle here formed by Tim's height and the length of his shadow. Okay, so we're going to go ahead and pull that triangle out. We know that Tim is 1.65. So that's one side of our triangle. Okay. And we need to know the difference between 16.60 and 12.45 so we can figure out this length here. Okay, so if we subtract them, we end up with 4.15, and that's this distance here. So that this part plus this part would equal the whole. Okay, so this is 4.15. Our second triangle is formed by the height of the flagpole and its shadow and back to the top. Okay, so we're going to go ahead and take that triangle out and redraw it. And we're trying to figure out the height of the flagpole, so we'll keep that as x, and then we know the whole bottom there is the length of the flagpole shadow, which is 16.60. And there's our two similar triangles, although we don't really know that they're similar yet. However, because they were talking about the height of the person and the height of the flagpole, we do know that that height has to be perpendicular to the base. And also, if you look at the original picture, the angle of the big triangle and the little triangle have the same angle right here. Okay? That's what they call the shared angle. It's the same angle in both triangles. They call it reflexive. And so that these two triangles are similar by angle-angle similarity. And because they're similar, then their corresponding sides are in proportion. And a proportion is a fraction equal to a fraction. So if we go ahead and set up our first fraction of 1.65 over the corresponding side of x, that should equal our 4.15 over its corresponding side of 16.60. And now all we have to do is cross multiply. This will be the easy cross. 4.15x is equal to 1.65 times 16.60, which is 27.39. And we'll divide by 4.15. Oops. And x will come out to equal 6.6, and that's meters. And that is the height of the flagpole. All right. All right, so going down, we're going to talk about the mid-segment theorem. Okay? And a mid-segment theorem, we've heard mid-segment before. It comes from the connection of two midpoints. It says if a line segment joins the midpoints of two sides of a triangle, the segment is parallel to the third side. So when they find the midpoint of AB and they find the midpoint of BC and they go ahead and connect it, every single time this side here, the segment that they call a mid segment that connects the midpoints, will be parallel to the third side of the triangle. And because they're midpoints, the length will be 1/2 the length of the third side. Okay. And so what happens here, okay, is that this triangle here and this triangle here are similar. Okay. Because these two lines here are parallel, these are corresponding angles. Okay. And so there's one in the blue and then one in the red. Corresponding angles are congruent when the lines are parallel. Okay. And then there's another pair over here. This one here in the little triangle. Because the lines are parallel, corresponding angles end up being congruent. And so these triangles are similar by angle, angle similarity. Okay. We could also be an overachiever and say up here at angle B, that's a shared angle. It's the same angle in the little triangle as it is in the big triangle. Okay. And we could be an overachiever and add an extra A to our theorem if we wanted to. Okay. And so what happens is that if this side, let's say, is 12, okay, which is in the big triangle, well, then this side here is 6. And therefore, you can now see your scale factor. If we're going from the small triangle to the big triangle, our scale factor is times 2. Because the triangles are similar, there has to be one scale factor that works for all three sides. Okay? And you can see that if we do it on this side as well. If this side is, let's say, 20, okay, then because E there is a midpoint, then this side ends up being 10. And again, the scale factor of 10 times 2 equals 20 works. Okay? If we do it obviously to the last side, let's say that this side here is 30 on the bottom. Well, again, if the triangles are similar, there has to be the same scale factor that works for all three sets of sides, and therefore this side ends up being 15, because 15 times 2 is 30. And so now you can see the relationship between those two parallel sides is that its length is half the length of that third side. Okay? All right, and again, this only happens when you have a mid-segment. It only happens when you have the two midpoints of the two sides and they're connected, okay? So D is the midpoint of AB, E is the midpoint of BC. Therefore, the triangles are similar by angle, angle similarity because that side ends up being parallel, and parallel lines create equal angles, and equal angles create similar triangles. Okay? And therefore, similar triangles have a scale factor, and when those are midpoints, the scale factor is 1/2. Okay? If you're going from the big triangle to the small triangle, or if you're going from small triangle to big triangle, it's 2. All right, so let's take a look at what they have down here. It says in triangle ABC, it says D is the midpoint of AB, and E is the midpoint of AC. And so as soon as I read that, I'm automatically thinking mid-segment theorem. Okay, and that tells me that my scale factor is equal to 1/2 or 2, depending on if I'm going from small triangle to big or big to small. Okay? And then it tells us that BC is 7x plus 1, and that DE is 4x minus 2. And they want us to find the value of x and then plug it in to find DE and plug it back in to find BC. Well, again, I know that this smaller piece here, DE, is going to fit into BC not only once, okay, but then a second time. And so it's going to take two 4x minus 2s to equal a 7x plus 1. Okay, or we could take half of 7x plus 1 and equal to 4x minus 2, either way. All right, we're going to go ahead and distribute, and we end up with 8x minus 4 equals a 7x plus 1. I'm going to go ahead and subtract 7x, and we end up with x minus 4 equals 1. Add 4, and x comes out to equal 5. And that's one of the things they asked me to find, but they also asked me to plug in. So this is going to become 4 times 5 minus 2. And so now we can say that DE ends up being 20 minus 2, which is 18. Okay. And we can either double it times 2 and get this one to be 36, or we can plug in 7 times 5 plus 1 and get 36 that way. And so we can say BC equals 36. All right, and there's that question. All right, number 2. It says in triangle ABC, points D, E, and F are the midpoints of the sides AB, BC, and CA respectively. What respectively means is that D was the first one to be mentioned and AB was the first one to be mentioned. Therefore, D is the midpoint of AB. Okay? E was the second one to be mentioned. BC was the second one to be mentioned. So I'm going to find the midpoint of BC and call it E. Then it says that F is going to be the midpoint of CA. Okay? And then it tells us that AB is 24, that BC is 22, and that AC is 20. And they want me to find the perimeter of triangle DEF. And we don't have triangle DEF yet until we connect D to E to F. But there's the triangle formed by connecting the midpoints of my original triangle sides. And so because those were midpoints, we have the mid-segment theorem. Okay. And therefore, the side that's parallel to the side of 20 is going to have half the length. And so if I see that this is 20 here, I know that the side parallel to it is going to have the half the length. And so I can go ahead and fill this length in as 10. Okay. The side that had a length of 22, the side that's parallel to it will have half its length. And so half of 22 is 11. And my third side of 24, the side that's parallel to it, will have half its length, and so 12. And now I can take that small triangle and find the perimeter of it now that I know all the sides. So 10 plus 11 plus 12 is 33. Let me just show you one other way that you can end up with the same answer, and it might be easier for you. But either way works. If I find the perimeter of the large triangle, so 24, 22, and 20 would give me the perimeter of the large triangle that ends up being 66. I can then apply my scale factor to the perimeter and end up with 33 as well. All right, so 2 different ways of figuring out the answer. Both ways work. Okay. Let's take a look, guys, at number 3. And it's saying that if G, H, and I are midpoints of AC, AB, and BC respectively, find X. So this one's not about the lengths of the segments like the last 2 were. This one's more about the angles. And because those are midpoints, the lines end up being parallel. And because the lines end up being parallel, we end up with a bunch of corresponding angles. For instance, my 40 can go there. Okay. The 61 that I have on this side can come up here. Okay. Let's see, where else can we go? Let's see. If we trace over some different parallel lines, for instance, here, you see those? And I can go ahead and use this maybe as my transversal, but I can take that 61 and put it over here as the alternate exterior angle, or alternate interior angle, excuse me. Okay. I can do the same thing with a couple other parallel lines. Let's say if I use this and this as my parallel line, that is my transversal. I can take the 40 and do the same thing and put the 40 here as the alternate interior angle to this 40. Okay? And then you guys can see that I'm down to that triangle here in the middle that only has one angle left to find. So I can take 180 degrees. I could take away the 61, take away the 40, and I could be left with 79 degrees for angle X. All right. So they could ask you, if you're given those midpoints, could ask you an angle question. Since the lines are being parallel lines cut by transversals create equal angles. Okay. Or they could ask about the length and knowing that the parallel side is half the length when those are midpoints. All right, guys, I'll see you guys on the back side of notes.